Alrighty, welcome. So today we are talking about isosceles triangles. So our goal is to examine and apply facts about isosceles triangles and use these facts to construct a formal proof. So here's how it's going to work. I'm going to kind of walk us through this, trusting that you will pause the video when I ask you to pause, try out some problems when I ask you to try them out. If you're just going to copy down what I'm writing, then kind of defeats the whole fun of this. So we'll start with our warm-ups. So what I'm going to ask you to do is work on those for a few minutes. And then once you're done with that, you're going to come back and I'll go over them kind of quickly. You can just do numbers 1 and 2 and just, again, give those a shot, pause the video, and then when you're done with those, come back. Okay, so you should be done with your warm-ups. So let's go through this. So the first one says if the vertex angle of two isosceles triangles are congruent, then the triangles must be. So let's just, I always like a good picture. So here's our picture. Again, I don't want to assume anything about the triangles, so I'm just going to assume they're both isosceles as directed, and they have vertex angles that are congruent. So let's give it a nice easy number. Let's say this one is 80. If that top vertex angle, and again, the vertex angle, just so we're remembering, is the angle that is not one of the base angles. If that vertex angle is 80 there, then I guess it would be 80 over here as well. Again, a lot of you are going to assume and draw pictures of the same triangles. That being said, one of the key things is that if this top angle is 80 here, then we do know that our base angles are congruent in an isosceles triangle. So if this top guy is 80, then we're going to take the leftovers in the 180, which would be 100 degrees, split it in two, and we have 50 each. So we have a 50 there and a 50 there. We use that same thinking over here on this other triangle. We're going to come up with, guess what? The same numbers again, 50 and 50. And so the reality is it should be kind of clear to see that the triangles are definitely going to have congruent corresponding angles. Does that mean we know anything about the sides? And the answer is we don't. So this could be, a 7 and a 7, and this could be a 10 and a 10. So we don't, in fact, know that the triangles are congruent. We do, though, know if they have all congruent angles that they must be similar. So yeah, those triangles are similar. All right, number 2. In the diagram below of triangle ABC, the measure of the vertex angle is 80. AC is extended out here to D. What's the measure of angle BCD? So this angle out here is what we're looking for. So right away, again, key idea is that when the two sides of an isosceles triangle are congruent, then we know that the opposite base angles are also congruent. So this guy and this guy are also congruent. So right away, same number as before. Didn't actually do that on purpose. Interesting. So if this guy's 80 here, we could kind of figure out, again, we're going to take the 180 minus 80. We're left with 100 split between these two guys. Looks like a person. So that's going to give us 100 split between 2 gives us 50 each. So each of those angles is 50. And then you can kind of attack this one of two ways. One way is to say, okay, well, if that's 50, then these two angles here are supplementary. And so if we've got a 50 on the inside there, this guy out here must be 130 because they're supplements. The other way is to think of this as an exterior angle of the triangle, which it is. And so he must be equal to the two non-adjacent interior angles or the remote interior angles. So if we took that 80 and that 50 together, we would get that 130. So that would be our final answer there. All right. So number 3, I'm just going to kind of go through with you. So these are just a reminder of some of our have-gets for isosceles triangles. So let's look at these first two on the left first. Switch back to purple. So if we have two congruent sides of a triangle, one idea here is that you could go the route of, and again, we're going to have different options with different triangles. Two congruent sides of a triangle can be enough to get us to say, oh, this triangle must be isosceles. And then the other option would be if you know that you have an isosceles triangle, that should say triangle, then you would know that you have two congruent sides of a triangle. Okay, and so those are kind of the converse of each other. There's that word again reminding us. So if you have two congruent sides of a triangle, you can say he's isosceles, or if you know you have an isosceles triangle, you know you get two congruent sides. All right, similar idea. If you have two congruent base angles of a triangle, you can get two congruent opposite sides. And then again, similar idea. The converse, if you have two congruent sides of a triangle, you can get two congruent, we can just say opposite is fine, opposite angles. You can also say base angles there. And now technically over here, if you have an isosceles triangle, by formal definition, two congruent sides is what we're looking for, but you can also say that you get two congruent base angles with that same kind of idea. So those are some of the have-gets we need. Again, the general idea is you've got two congruent sides, you get two congruent angles. You have an isosceles triangle, you get any of those properties that you have. So to prove a triangle is isosceles, so this is now, if we wanted to show something is isosceles and convince somebody of that, you need to show one of two things. Again, formally, you need to show that it either has two congruent sides, or the other choice would be two congruent angles. And again, that's an or. So that's an or. Because sometimes people think they have to show both. You do not have to show both. All right, so that's our warm-up for lesson 26.